For example 5 in day 1 notes, this is called the product of powers property. So you can see that we are multiplying the bases. So the bases here are x in all 3 of these, and then our exponents or our powers are 3, 2, and 4. And so what occurs is that you have to add your exponents when you multiply the same base. And that's written here too. To multiply powers having the same base, add the exponents. And so if you were to show work, it would look something like this. But if we add those, 3 and 2 make 5, and 5 and 4 make 9. So this would be our solution, x to the 9th power. Okay, so in part B, we see that we have the same base, and it's being multiplied, so we will add the exponents. So 4 and 3 make 7. And then in letter C, this is just implying that they're multiplied. If they have the parentheses like that, it's just showing that there's a negative with the 5 in both of these. The base is the same, but we really know that the bases are being multiplied. And so I would get negative 5 and negative 2 plus 7 is 5. So this would be my solution, negative 5 to the 5th power. In letter D, same base being multiplied. So negative 6 plus 4 is a negative 2. But in this day of notes, you learned that you cannot have negative exponents. And so you would need to put this over 1, and you would need to flip the fraction to be 1 over 3/2. Never would you leave an answer with negative exponents. You will always have to go back and flip it or move it somehow in the fraction. Okay. Moving on to letter A in example 6. Multiplying powers and algebraic expressions. What is the simplified form of each expression? So in this one, you see that this 4 and this 2, okay, they're kind of like by themselves, kind of isolated. You have to put them together. So how do you do that? Well, what is 4 times 2? That is 8. And then because the m's are the same base, you would go ahead and add those exponents. So 4 and 2 would become 6. Okay. So B is the same exact idea. That 4 and 9 we multiply, we get 36. The z to the 5th and z to the negative 12th, we would combine those. So 5 minus 12 is negative 7. But we know we can't have a negative exponent, so we're going to put this over 1 and flip only the negative exponent. So you have to remember that 36 really has a positive 1 there, so it stays. The z would move to the bottom, and we change it to a positive. Okay, so this is your final answer for letter B. Alright, and then in C, we have a few pieces, but it's very similar to A and B. So the 4 and the 5, you want to go ahead and multiply those. So we would get 20. Your B's, you'd want to combine. And so B to the 4th and B to the 3rd would give me B to the 7th power. And then C and C squared. Well, this C has an invisible 1. You'd want to write that in. And then that would mean 1 and 2 would make 3. Everything has a positive exponent, so this is my final solution. Okay, then in letter D, the 2, 9, and 3. Those are all whole numbers that we can multiply together. Okay, so I know that 2 times 3 is 6, and 6 times 9 is 54. Then if we look, you have an A, a B, and an A. So when we add exponents, we can only add exponents that have the same base. So our A, we can combine. But our B will just come down at the end. So A to the 1st, A squared makes A to the 3rd. and then b to the 4th just comes down. Everything is positive, so I'm good to go. Then for the last two, we're going to still add exponents. So we have 1/5 plus 2/5. So when you're adding fractions, you have to have a common denominator, which I do. They're both 5. And so I would leave the denominator 5, but I need to add the numerators to be 3. So my answer is a to the 3/5 power. And in P, or in F, letter P, we have 6's. So it's a common denominator again. And if we add the numerators 4 and 1, we get P to the 5/6 power. And please note that you want to make sure that those fractions look like exponents. So they don't want to be down here where the P is. They need to be up here in the corners. Okay? All right. And that is it for day 1.